Hey everyone, welcome back. Today is day 5 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on video. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was on statistics and machine learning. Right now, I'm at top 0.3 on LeetCode, and like most of you, I love LeetCode. Over the last few days, we have tackled problems based on sliding window, two pointers, prefix and suffix based problems, and also problems based on strings. Today, we will focus on stacks and we'll solve problems based on monotonic stack, greater or smaller elements, and problems of such natures. These problems teaches us structure, flow, and how to handle state across elements, which is key in interviews. Before I begin, if this video helps you, please drop a like and consider subscribing. You can also share my videos with your friends. That will help me a lot. Let us begin. So today we are tackling problem 739, daily temperatures on LeetCode. And it says that we have been given temperature array, which represents daily temperature. And we have to return an array answer such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. But if there is no future day for which this is not possible, we just keep the answer of I as 0. These are the constraints. These are the examples. Let us go to the dashboard and we will try to solve it in an optimal manner. Okay. And at the dashboard, we have been given a temperature array where these are the temperature span across several days. And we have an output array which represents the output correspondingly. Okay. Now we have to return output in such a manner. For example, if I'm standing at any specific day, for example, if I say this day, okay, so the output must be the number of days we have to wait from this day such that we get a warmer temperature. Right now, I'm at 71. So what is the warmer temperature? Temperature greater than 71, right? And which is the first temperature that is greater than 71? Is it 69? No. Is it 72? Yes. How many days is it? Day 1. And on day 2, we get 72. So it should be this, right? Answer 2. For example, if I'm at 73, how many days do I need to wait to get a warmer temperature? Warmer temperature means any temperature value greater than 73. Is 74 such a temperature? And the answer is yes. How many days starting from 73 did we have to wait to get a warmer temperature? 1 day, correct? Just one, correct? And that is the answer. How about this case? If I'm at 76, how many days do I need to wait to get a warmer temperature? Let us see. I'm at 76. The next time I move to 73. Is 73 greater than 76? No, which means 73 is not warmer than 76. What is the next point I should look at? Next point I should look at is such a value which is outside of the array. But since that will be incorrect and invalid, which means 76 has no such temperature which is warmer than 76 for this specific case. For this specific date, there is no such temperature ahead in the future that is warmer than 76, at least for this example that have been given to us. Okay. So in that case, the value at this position will be 0. Similarly, the value at this position will be 0. One thing that you must notice is for any and every single value at the right hand, its value will always be 0, right? Because the next temperature that we have to look at will be the temperature beyond the array scope, right? Which is something which will be invalid. So in that case, we have to print 0 or place 0 over there. Okay. Let me walk you through this problem in a pictorial or diagrammatical manner. Okay. Suppose these are the various temperature bars spanned across 4 days, and these are the temperature bars that has been spanned across 4 days. Now, at the index 0, at day 0, let us see. Is this the greater temperature than this one? No. Is yellow the greater than this one? No. Is this the greater than this one? No. Is this greater than this? Yes, it is, right? Just look at the magnitude, correct? Its bar is higher than this bar. So this temperature is the greater temperature than this one. And this temperature is the first temperature which is greater than this one. So for this specific case, how many days do we need to wait? 4 minus 0, which is like we have to wait for 4 days. Is that the case? Starting from here, 1 day, 2 day, 3 day, and 4 day. How are we computing for? We are computing for by taking the index of such a day where the temperature is greater. Let us suppose that is index I, subtracting that with the current index I am standing at, okay? So in that case, in this case, it is 4 minus current index 0. So the answer is 4. Similarly, we'll follow it for the remaining one. Is this greater yellow than blue? No, it is not. Is this pink greater than blue? Is it? No, it is not. Is this blue greater than this deep blue? The answer is yes. So 4 minus 1, it should be 3, correct? Similarly, for this, it should be 2. For this, it should be 1. And for this, it should be 0. Why 0? Because it is at the end of the array, right? It is at the right end. And I stated, and as I stated above, for any and all values at the end of the array, the next temperature that we'll be looking at will be beyond the scope of the array. And since that lookup will be impossible, not impossible, it will be invalid. So in that case, the value at the right end will always be 0. Okay. So that is the case as in over here. So we can blindly put 0 over there as well, right? And we can make a check. Is this the greater blue greater than the pink one? And the answer is yes. So it will be 1 minus 0 and it is 1. How about this one? How about this one? Is pink greater than the deep blue? No. How about white? Is it greater? No. Is yellow greater than the deep blue? No. So we scanned the entire array and we found no temperature that was greater than deep blue. So the answer is 0. For this pink one, yellow is greater, not white. So the answer will be 4 minus 2, which is like 2 days, which should be obvious. It should be obvious, right? Because this is 1 day, this is the second day, correct? And just to conclude it, for this one, it will be 4 minus 3, which is 1. And since it is at the end, it will be 0, right? So yeah, that is all there was to this problem. Now, how did we solve this problem? One of the core crux of this problem is to use monotonic stack. Monotonic stack. What does monotonic stack means? Monotonic stack means stack in which elements are either increasing or decreasing. In our case, we will be using monotonic decreasing stack, which means we will keep assembling elements into the stack as long as they are smaller. But every time we encounter an element that is greater than the previous element, in that case, we'll pop the previous smaller element and we'll keep on popping as long as the current one remains the greater one, okay? For example, in this case, we kept on pushing to the stack this until we encountered this element, which was the greater among all those elements, right? So what did we do when we encountered such an element which is greater than all this previous? We kept on popping. We popped this. We popped it in the reverse order they were placed in. They were placed in this order, popping happened in that order, right? It should be obvious. Let us look at the code and we'll try to understand the solution. First of all, we declare result array and assign every value to 0 and declare it of length equal to the length of the given array, which is temperature. And this result array is something that we will return at the end, as you can see over here. Then we declare a stack. Why stack? Because we will be pushing and popping all values of the stack itself. And the structure of the stack will be the first value of the stack at any position will be temperature, followed by index which the temperature was spotted. Okay. Then what I did, then I scanned through the entire loop, through the entire length of the array using the I loop, using the loop where the iterator was I. And as I'm doing this, the time complexity is bounded by linear, which is order of n. Okay. Now within the loop, the first thing I ask is, hey, is my stack existing? If my stack is existing, I ask, hey, is the current temperature that I'm looking at, hey, is it greater than the temperature on the top of the stack? It is something similar to this. Hey, the current temperature that I'm looking at, hey, is it greater than the temperature on the top of the stack, which is this? The answer is this, pop this. and keep on popping all those previous elements as well. That is what we are doing. If the current temperature, if it is greater than the temperature on the top of the stack, then please pop it and store the temperature in T and the index in IDX. And this index is the index where this temperature was associated with, right? So we go to the result array at that specific index, we subtract this I minus IDX, which is more like index minus current index minus current index, which is something that we did over here, right? Index minus current index computation. And we store the value in the result at IDX. This IDX is the index associated with the temperature that was popped out, okay? And once we break out of this while loop, we store the answer, we push again back into the stack, in the structure, temperature at index I, along with the index where the temperature was placed, which is at index I, correct? Once that is done, once we exhaust the entire loop, we come out of the loop and we return the result. So the time complexity of this thing will be order of n, and the space complexity, my bad, I think I missed the pair. Just give me a second. Okay, so the time complexity will not be just order of n. In fact, it will be order of n times order of some factor. You can estimate this factor, which is coming from this while loop. Okay, order of n is coming from this for loop, and this order of f is coming from this while loop. Okay, and the space complexity of order of n is coming from this in and this stack. Okay. So yeah, that was all there was to this problem. I hope I've explained you and you have understood everything that I was trying to explain and the significance of using monotonic stack using these two diagrams, and then how I correlate these two diagrams, especially this one with the code over here, and how these are getting stored in this part, and the importance of while loop and why we are making a check and this all these sticks and what does it even mean, okay? And how the structure of stack is and how it is getting pushed over here, right? And the result is getting returned over there. So yeah, that was all there was to this code problem. Let us go back to the LeetCode dashboard and we'll try to submit this. I've already submitted the solution, so I'll just copy and paste my code and I will run it down. And as you can see, the solution has been accepted and the test cases has passed. So yeah, that was all there was to this problem. I hope you understood what I was trying to explain. If you have any doubts, please leave it in the comment section and I will definitely address that. Okay. Till then,